Okay, last problem here. Let S naught, the position function, equal, notice I have a little typo here. I wrote negative g, but g is a negative value, so I'm not trying to cancel out that negative. So it's just saying g over 2 times t squared plus v naught t plus s naught. It's the normal position function, even though it looks a little scary. So we want to write the equation for the height of this object. So we're going to write s of t. Wow, that equation's all goofed up. I wrote s naught. I meant to write s of t. I put this together late. I'm sorry about that. S of t equals, notice we're in feet, so we're going to be negative 16 t squared plus our initial velocity, which is 64 feet per second, times t, plus our initial height of 40 feet. And we want to know at what time t does the object hit the ground. So go ahead and graph this in your calculator. Go ahead and make, I would do like 50 or 60 as your y max, because we know it's going to be thrown up and it's starting at 40. So we know it's going to have a y-intercept of 40, but then it's going to go up from there and come back down. So let's figure it out. I don't know, try an x value of maybe like 10, see what it looks like. So if you do that window I just suggested, you get essentially a graph that looks like this. Pretty crappy, you can't see anything. You have way too much x and not nearly enough y. So I'm going to modify that. I'm going to do, let's see, I'm going to change my x maximum to 6, and I'm going to change my y maximum to 80 and see what that looks like. And holy crap, you still can't see the top. So let's go even higher. I'm going to go 150 for my y max. And there you go, you get a nice looking parabola. And we want to know at what time does the object hit the ground. So we need to find this 0. So in order to do that, hit second, calculate. Option 2 is 0. It says left bound, so move your cursor to the left. And then right bound, so move your cursor all the way to the right. Make sure your y values are negative before you hit enter, and then you can hit enter for your guess. And you should get an x value of 4.549. But another way to find the 0 that I prefer is to graph the line y equals 0, because then you can just calculate an intersection point, which in my opinion is much easier. And we get the value x equals 4.549, just like before. And now we want to know at what time is the velocity of the object negative 20 feet per second. So to answer that question, we need to graph the derivative of this. So you can actually use the power rule and come up with the derivative function, or you can just use the n-derived feature on your calculator. Either way, find the derivative, and then graph the line y equals negative 20 and find the intersection point. So you should find that that happens when x is 2.625. And then the last question is, what is the velocity of the object when it is 10 feet above the ground? So you need to figure out when it is 10 feet above the ground. So graph the line y equals 10. And then look at the intersection of that and your original function, the parabola. Calculate that intersection point, first curve, second curve, make sure you put it on the line, then the intersection point. You should get 4.423. 4.423 is when the object is 10 feet above the ground. And now go ahead and jump to your derivative and find the value of your derivative at that x value, 4.423. And you should get negative 77.562. Negative 77.562.